Good day everyone. Today we have come to the last part, that is colligative properties of chapter 1 solution of class 12, and we are going to complete the colligative properties in two videos, that is part 4.1 and 4.2, where we will be studying and completing all the colligative properties in detail. Colligative property. So the word colligative has originated from a Latin word where co means together and ligate means to bind. So the properties of solutions which depend only upon the number of solute, they only depend on the number of solute irrespective of their nature. Relative to the total number of particles present in a solution, those are called colligative properties. So colligative properties are those properties which only depend upon the number of particles but will not depend on the nature of particles. So the four important colligative properties are relative lowering of vapor pressure, elevation in boiling point, and the depression freezing point, and osmotic pressure of a solution. So first we will deal with the relative lowering of vapor pressure. So in the relative lowering of vapor pressure, we have already studied that by adding the non-volatile solute to a solvent, the vapor pressure will decrease. So Rawls has established that relative lowering of vapor pressure depends only on the concentration of the solute particles and is independent of its identity. So let us assume that x1 be the mole fraction of solvent and this should be the mole fraction of solute, and P0 will be the mole fraction of pure solvent. So according to Rawls' law, we know this particular equation. So the reduction in the vapor pressure of the solvent would be, the vapor pressure of the solution should be separated from the vapor pressure of the pure solvent. So by further solving this equation, we come to the conclusion of this equation, which is very important, and this is called the relative lowering of vapor pressure. So it depends only upon the number of moles of solute and solvent but will not depend upon their nature. And a very important point we have to note is that relative lowering of vapor pressure is a colligative property, while lowering of vapor pressure is not a colligative property. So the word relative makes a very big difference, because relative lowering is a colligative property while lowering is not a colligative property. Now we will understand how do we find the molar mass of the solute. So for finding, first we have to assume certain things, that for the solvent the mass will be considered to be W1 and the molar mass to be M1, and for solute the mass is W2 and the molar mass is M2. So we know that mole fraction of the solute can be calculated by number of moles of solute by total number of moles of the component. So we know that moles can be calculated by given mass by molar mass. We already assumed the given mass to be W2 and the molar mass to be M2. So we'll substitute the values and we'll obtain this formula. So it is very important to note that for dilute solutions, the solvent will be much more greater in quantity than the solute. So the solute will become almost negligible in our calculations. So we'll eliminate the value of solute and come up for this conclusion. By substituting this value in this equation, we'll get the equation to be this, and then we will equate it to our relative lowering of vapor pressure equation, and then we'll obtain this N2 by N1. Then the final answer is this. So we can find the molar mass of solute by this formula, which is very important. This is a question for you to solve. Next, moving to the elevation in boiling point. So firstly, what is boiling point? So boiling point of the liquid is that the temperature at which its vapor pressure becomes equal to the atmospheric pressure. This is very important to note. And let us take one example to understand the elevation in boiling point. So the water will boil at 373.15 Kelvin. So at that particular stage, the vapor pressure becomes equal to the atmospheric pressure. But however, the vapor pressure of the solvent will reduce in the presence of a non-volatile solute. So we know that water will boil at a certain temperature, but in the same, if we add 1 mole of sucrose in 1000 grams of water, then it will boil at 373.52 Kelvin. So there is an increase in the boiling point. So the difference in the boiling points of the solution and the pure solvent is called the elevation in the boiling point. This is very important to remember. So this is a colligative property because the elevation in the boiling point will depend only upon the number of solute molecules rather than their nature. And further experiments have shown that for dilute solutions, the elevation in boiling point is directly proportional to the molar concentration of the solute in the solution. So when we remove the proportionality sign, we'll get a constant, which is the constant of proportionality called the molar boiling point elevation constant or abelioscopic constant. And the units of Kb are as follows. And if the molality is 1 molal, then the delta or the change in the boiling point will be equal to the constant of proportionality, and thus the molar boiling point elevation constant, that is Kb, is defined as the elevation in the boiling point for 1 molar solution. Now we'll study how to find the molar mass of the solute. So here we assume that W1 gram of solvent and W2 grams of solute with molar mass of M2. So we know the formula of molality, that is moles of solute by the weight of solvent in kg. If we take in grams, we will multiply with 1000. So we know that the moles of solute can be calculated by the following, with as given mass by molar mass. By substituting that in the molality formula, we'll get like this. And then we know the formula that the elevation in the boiling point is equal to Kb into M. So we know the M value and we'll substitute this in this, and then we will be able to find the molar mass of the solute by the following formula, which is very important. The question is provided for you to solve. Now moving on to the depression in the freezing point. So what is the freezing point? The freezing point is that the temperature at which the solid and the liquid states of a substance have same vapor pressure. So when a non-volatile solute is added to a solvent, the freezing point of thus formed solution is always lower than that of the pure solvent. So the freezing point of the formed solution is always lower than that of the pure solvent. So the variation in the freezing point is known as the depression in the freezing point. So here Tf naught is the freezing point of the pure solvent, and this is the freezing point of the solution. So the variation is known as the depression in the freezing point. And for dilute solutions, Same as in the case of elevation in the boiling point, it is directly proportional to molality. And if we remove the proportionality sign, we will get a constant. And then that is called the freezing point depression constant or the cryoscopic constant, whose unit is found to be this. And if m is equal to 1 molal, then our depression freezing point will be equal to the constant. So the molal freezing point depression constant is defined as depression in the freezing point for 1 molal solution. So we can find the molar mass of the solute in the same way we found in the elevation of boiling point. There are some important relations which you have to remember, that is relation between enthalpies change and constants. So these are the two equations which you have to remember, which are provided in your NCERT. Here R is the gas constant and M1 is the molar mass of the solvent. And here change in H represents the enthalpies. Here it represents enthalpy of fusion and here it represents the enthalpy of vaporization. A question is provided for you. So until now we have completed the first colligative property, that is relative lowering of vapor pressure. The second one is elevation in the boiling point, and the third one is the depression in the freezing point. So the fourth one, which is osmosis, will complete in the next part, and the solutions to these questions will also be provided in the next video. So now we'll give a quick NCERT reading to whatever we have completed until now. So in the NCERT we have basically started the colligative properties and how to find out the molar mass in this video. So there are 4, that is relative lowering of vapor pressure, depression of freezing point, and elevation of boiling point, and osmotic pressure in the colligative properties. So the first 3 are completed in this video and we'll complete osmotic pressure in the next part. And the colligative, the word comes from Latin, where co means together and liger means to bind. So first, that is the relative lowering of vapor pressure, and we understood what is relative lowering of vapor pressure and how do we get the equation and what is the final equation. In text questions and example questions are provided. Next, the elevation of boiling point. We understood what is boiling point and what is the change in the elevation in the boiling point, and a graph is provided where we can understand that the boiling point of pure solvent is less than the boiling point of the solution, and the variation in this will give us the elevation in the boiling point. And we understood for the dilute solutions that it is directly proportional to molality, and we understood the ebullioscopic constant and its units and how to find the molar mass of the solute. And then the depression in the freezing point, and a graph is provided for us. And here the pure liquid will have greater freezing point, and here also it is same as in the elevation of boiling point, and here we have cryoscopic constant, and these are the 2 important relationships we have to remember. A table is provided and questions are given. So in the next part we will start with the osmosis and osmotic pressure and we'll wind up this whole chapter. Thank you so much for watching.